All right, so welcome back. I got some really good news. The good news is that I am taking, as we speak right now, you are watching a second video on today, Friday, the after work video. I used to be doing 2 videos a day, but I just got bogged down. And luckily I was able to keep doing the lunchtime video, but the after work video was just too much for me. So it's really good news that I can pick this back up again. Burnout is a thing that can happen, so it is something I'm aware of and I'm hoping not to fall into. But the test is going to be in about a month right now, so I really don't think a month of work is enough to completely burn me out. And then once I take the test, whether pass or fail, I'm going to be done with this. So I really don't need to worry too much about over study or overtaxing myself, because it's just going to be a short period of time in which I really have my foot on the throttle. Okay, so this is going to be the 3rd video. And in the last video, we were configuring the IP addressing on the devices. Let's see if the devices are up now, because I bumped the cron job back by a half hour. They should have, aha, so yep, now we're at the login prompt. Perfect. Let's do a show chassis PIC or show chassis FPC 0. Okay, I don't. So I'm hoping I can get a presence status showing up. But it is good news that it went to the login prompt instead of being stuck here. Okay, so there seems to be some issue where it's not able to run the command I entered. Let's try it on a different router. Okay, so this other router, okay, there we go. Perfect. So that could be a sign that there are issues with the FPC. But as I mentioned before, you can still configure things even though the forwarding plane is having problems. So this is going to be the 3rd video. And last video I was configuring ports. I think I got through G, I'm not sure. I will double check. So let's open up G again. Hopefully G's no longer stuck in limbo. It looks like it is. Okay, so let's move on to H. Actually, let's start with E. I'm pretty sure I configured E already, but it'll be a good refresher as to what I was configuring. Yep, so I configured E already, and we've got a convention here where 0 is here, 1 is here, so 1. Okay, so 0 should be the higher number, yep. Okay, so let's see if this has been configured. There we go. 0 should be the higher number, perfect. Okay, so I'm pretty sure I did get to G and I stopped at H, but we'll verify. Yep, so, okay, so now I don't think I've finished H yet. Let's take a look. Okay, so I did finish H, but I'm pretty sure I didn't get to K. Although I was similarly sure that I didn't get to H, so who knows. Okay, so this is going to be, if this is, these are all zeros, these are all ones, so this is going to be port 1. On K, it's going to be, okay, well K, oh, right, I have the labels, I constantly forget about that. Oh, here we go. So yeah, so 1 is going to be 8.2. Okay. Alright, I thought I opened J. Try it again. Okay, so J is not opening. Okay, there we go. Now it's open. Alright, so J gets, let me see if I can get the labeling. I'm pretty sure it's going to be, yeah, 1, 0, so J is going to be 1 here. Yep. Okay. So it's going to be .8, I believe. Unless it's .9. No, it is going to be .9. So this is router K. So, yep, K looks good. So we don't need router H anymore, finish that. So router J. Okay, so this is going to be .9.2. Excellent. So I, let's see here, time for I. Okay, so we've got the basic configs done, or at least the IP addressing. Oh, we are missing loopback addresses. I think I'm gonna add those next. Okay, so the next step will be adding loopback addresses. I'm not sure what convention I'd like to use. I guess I'll do 172 or 192.168.0.1. I'll use that convention. Okay, so make this easier on myself. Okay, so moving on to .2. And .3. Okay, so unfortunately I can't include the username and password. Okay, .4. .5. .6. And .7. .8. .9. Alright, .10, 2 more. .11 and 1 more. 8.12. So all of the IP addressing is out of the way, including the loopbacks. So now I'll just be following along with the documentation. So starting with router A, we're going to create, now router A is the CE router, so we won't need any sort of IGP, anything like that, because it's just essentially going to be in its own area, its own square like that. So, oops. See, I accidentally had multiple icons selected. So, yep, router A should be a pretty small config. So let's configure that. I'm not sure how to get my cursor back to normal. Oh, looks like it doesn't have to be any different than it is. Okay, so what we're going to do is create an Ebgp connection to the ISP. I forget what name I used for the ISP, but it's going to be the ISP that is purchasing the services of a second ISP. So, and that's going to be in peer AS21. This is going to belong to AS1. So let's start off by setting that. Autonomous system 1. Okay, so next step, we're going to be forming that Ebgp connection. Okay, so we're going to do export, set export, and then so it looks like they've got so they've got a policy where we're going to be exporting direct routes. I'm not sure why they did it in a policy. You can just do, oh no, it does have to be in a policy. Okay, that's good to know. Okay, so let's set that up. Set export attached. Okay, and we'll define it later. We're going to do a peer AS. It's going to be 21, and then we're going to do a neighbor. We've got a different IP scheme. So since this is an Ebgp connection, we'll be using the IP on the directly connected interface instead of the loopback. So that's going to be .1.2. Okay, so next step will be setting up that policy option. Okay, so everything I think looks good to go. Yep. Perfect. All right, time for the next router. Okay, so we've got things a little bit more complicated on this one. In fact, this is probably going to be one of the more complicated ones since it's a PE, provider edge routers are typically the most complicated. We will need to, since we're adding these protocols to, these interfaces to protocols MPLS, we will need to enable family MPLS on the interfaces. Let's start with that. Oh, and the other thing is this documentation consistently has been inaccurate. The problem it has had is adding inappropriate interfaces to inappropriate routing instances. So when you add the interface to protocols MPLS like this, you are adding it to the default routing instance, but you can also add it to a custom routing instance. For example, here is routing instance VPN A. So what they mean to do instead of add 102 to the routing instance VPN-A, which you can see they actually did, but they clearly meant to do this, but they're not going to be able to be successful doing that because you can see they already added it to the default routing instance. So when you do a commit, it will say, hey, I can't add it to your custom routing instance because you already added it to the default routing instance. So I definitely learned that the hard way, but I learned it and I learned it well. So what we're going to do is just add the interface to the default interface that needs to be added, and then the other interface will add to the routing instance. How do I know which one belongs to which? Well, the routing instance, the custom routing instance, that serves as the front door to the VPN. So of course the port that is facing the customer device, that's the port that gets added to the custom routing instance. And then the port facing my own internal net gear just gets added to the default routing instance. There's no reason for that sort of traffic to be tagged with a special VPN or anything like that. It's just the customer traffic that you need to be protected. And you might say, oh, well, if you don't protect the regular traffic, you know, how are you protecting the customer traffic? Can't they get it that way? Well, no, they can't, because it's all encapsulated. So if somebody were to tap these links, they would just see the encapsulated traffic. And not only that, that gear actually belongs to the ISP too, so it's not like there's a shared link or anything like that. All right, so set interfaces there, so set family. Oops, why can't I? Oh, okay, I gotta do edit. So I gotta do set interfaces. So now it's gonna be the one facing, so the one that gets added to the default interface is the one facing router C. So that's gonna be interface 0. Family MPLS, but both of them are going to have family MPLS enabled on them. Where I need to select one or the other is where I would configure them to belong to either the default routing instance or the custom routing instance named VPN-A. So here's the default routing instance. So for this one, I'm going to be adding the port facing router C, which is GE000. Okay, so that's all I need to do. I also need to form a Ibgp connection internally. And I'm not exactly sure. Oh, I think I'm going to be forming it. Yes, I'm going to be forming it to the other PE. And the reason I need this is for my L3 VPN, because this is where my traffic is going to be, how it's going to be sent. It's going to be sent, oops, but, oh, but this is interesting. Because there's, oh, no. Yeah, it is going to be sent through there. It's going to be, I believe the import policy will have it go through there. Oh, it actually looks like I've got two neighbors, which I'm kind of surprised by. So yeah, I'm not really sure. And the other thing is, it looks like this second neighbor isn't nested within a group. It's just applied at the top level. So I'm not sure which. I'm not sure how this is actually meant to be configured, but I am pretty sure that there's some sort of mistake, just as there was here. And I have downvoted and sent, and they said that they've corrected it, but they would have corrected it only on the documentation that I specifically flagged. This is a widespread documentation flaw across thousands of different pages, probably tens of thousands of different pages. Okay. So here's the internal group. So we've got type internal, local address. So the local address is going to be, since this is an Ibgp group, it's going to be the loopback address, which will be .2. Okay, we are going to need an IGP as well. They're using OSPF. But let's finish up the configuration here first. Now, this is really interesting. I'm really not sure which neighbors they want me to form to, because I don't have. I guess let me try this. So hopefully the neighbor address is specified as the local address on some of them. Aha! So we can see it wants a neighborship to router D in this first section of configuration here. So let's do that. And this is going to be a neighborship to router D .168.0. So let's look up which. So .1, .2, .3, .4. So it's going to be 2.4. Okay, so for this neighbor, they want set family inet labeled unicast and then resolve VPN. So this is, yep. Okay, so yep, we've got everything looking good so far. They do want another neighbor. I'm not sure which neighbor this is meant to be, so let's see if it's specified as a local address. Aha, it is. So this is router I. They want to be a neighbor. So this PE here. So they're going to form a neighborship with their own CE there, and then with their P all the way across to the other side, so really long neighborship. And I'm not sure, so this is actually going to be a internal Ibgp session as well. It may seem counterintuitive because obviously it's simpler to think of it as external, since it's traversing through another ISP, and it's geographically quite a bit different than this one. But really the proper way to think of it is internal, because you can basically just think of this second ISP here as one long wire. That's the purpose of that second ISP. So it still is internal. It's just using a special setup to prevent the first ISP from having to buy expensive infrastructure to build out their own network. Instead, they can just rent from another network and treat it as if it were just one long wire. Okay, so we've got, so I think this indentation is a little bit off. I think I can just configure it under group INT. So I'm going to do that. So edit, protocols BGP, group INT, there we go. Then we're going to set neighbor, and it's going to be to router I right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then we're also going to need it to belong to family inet VPN. So this is IPv4 layer 3 VPN NLRI parameters. Yep, because remember, BGP doesn't exchange routes the same way as IGPs do. It exchanges information. So data about the routes is what is exchanged through BGP, not actual routing information itself. And that's part of the reason why it can scale up so well. Okay, so, oops, I don't see, okay, yeah, okay, everything looks good. So, oh, okay, yeah, this looks fine, I think. I guess I might have, I think I added, I want to do some change right here, some changes. So first I want to delete that family statement. Yep. Yeah. And then show pipe display set relative. There we go. And now I want to add that under the neighbor hierarchy level. Yep. So this should look a lot better. Yeah, so now it's nested more appropriately. Oops, I'm not ready to commit yet. Let's do edit protocols OSPF area 0. Yeah, and the other interesting thing is going to be that OSPF area 0 is going to expand here. These can be in the same area because the best way to think about this section is just one long wire. So just as you would configure OSPF if those were just directly connected to each other, that's how it's going to be configured in this case. Okay, so here we're speaking to the default instance again. So anything that is facing the customer is not going to go into that default instance. It's going to go into the special routing instance for the VPN. So we know that the port that belongs here is the port that faces away from the customer, which is going to be port 0. Okay, and one last thing to configure will be LDP. Okay, so yep, everything looks good so far. Time for the routing instance. Okay, so now this is going to be the interface facing the CE router. I'm going to be using a different route distinguisher as well. I use my own loopback address for that, and then I'll keep the number 21. That's the area. I don't think I set that yet, but I can come back and do that. Or not the area, the autonomous system number. Oops, so, so now we're going to have a neighbor statement for the Ebgp connection between the CE and the PE. So we know that when it's Ebgp, we're going to use those physical interfaces, otherwise we need to toggle a special knob to allow it to use multiple hops. Okay, so the physical interface is going to be 10.0.1.1. All right. Okay, so that's it for the routing instance. Let's see if I set up the autonomous system yet, and if not, just throw that on there quick. Yep, okay, so that's not on there yet. It's going to be 21. All right. So it looks like I did, I named it VPNA-0 for some reason. That's not going to be, unless it is going to be what I want. Yeah, okay, that is what I want. All right, so moving on to policy options. Okay, so now we're going to need to create a community. So policy options, yeah, so the community falls under policy options. So we already called it, but we didn't define it yet. So before this statement, things will fail, but this will cause things to succeed now. So if I do a commit check, everything should be good. We'll do a final show of the candidate configuration before we commit it for real, and then move on to router J. So unfortunately, it looks like commit checks take longer than I expected. That's because there's so many routers up and running, but the commit check did succeed. And the configuration, as far as I can tell, at first glance, looks pretty good. So yeah, let's commit it and move on to the next one. So router J should be quite a bit simpler, and it is. Perfect. Oops, and I don't know why. Oh, so it looks like against. So it looks like I accidentally configured PE router B with the configuration that was meant for PE router I. Now, I don't think there's going to be a problem with doing that because they're essentially going to be the same configuration with different variables swapped. But in any case, let's go up and take a look, because one thing that might be different is the target and the identifier used after there. So let's go back up to router B and then see how those differ. I might need to just make a few minor changes. Okay, so good news is it's got the same autonomous system. We knew that because this is the same ISP. It looks like the target is going to be the same as well. That's to be expected. They have to match. The only difference is it looks like they used a different group name. I don't think that matters, so I'll just keep it the way it was named. But everything else is exactly the same, so I don't see a reason to go back and change it, just to use that same group name and everything. So kind of lucked out. I did make a mistake on that, but it turned out to be benign. Okay, so time to move on to router D. Before doing that, I think I will make sure my OSPF and LDP neighbors are established. Oops, so it looks like we've got a problem where the OSPF neighborship isn't establishing. Neither is the LDP neighbor, so I think the reason for that is because my forwarding planes are having problems. You can see clearly I can't even do a show chassis without things freezing up. So there's something going horribly wrong with the forwarding plane right now. Let's see if just a reboot of them will change that. Okay, and then while that's rebooting, we can move on to router D. So router D has a similar error. Okay, well router D doesn't actually. I'm actually surprised by that. I thought it would have a VPN configuration on it. Because it's a, oh no, it's a CE router. Okay, yeah, I thought it was like a PD router. Okay, this makes more sense. So edit protocols. Oops, so one thing I forgot on router C as well is that I will need to enable family MPLS on the interfaces before adding them to protocols MPLS. Okay, so now I can move on. Oops. Oh, okay. So obviously I'm going to need a different local address. This is a Ibgp connection. I'm going to need to take a quick break. So let's get this local address configured. 1, 2, 3, 4. So this is going to be .4. Okay, and then I'll take a quick break. I'll be right back. Okay, so I am back. We're gonna keep going on this. We need to figure out what the neighbor is for D. I have a feeling it's gonna be router B. Oh. Oh yeah. So it's the local address of router B. It's called out in neighbor statements for a lot of other routers as well, but it's going to be the local address for router B, and router B is going to be .2. So set neighbor 192.168.0.2 family inet labeled unicast. Okay. Okay, so now there's going to be another neighbor. This one I'm not sure on. Let's see who this belongs to. So, okay, so this is pretty interesting. There's no yeah, there's really not a good clue. I have a feeling, well, actually I don't know, because this is, okay, well, this is interesting. I wonder which device this goes to. So it's going to go to ISP red, but so I'm thinking that it goes to the PE. It's just like a connection here, but I'm surprised that would be the case because it is a oh no, okay, yeah, see, I thought this said type internal. That's what confused me, but it's expert internal. So they used a really I think poor naming convention here. I would call it like internal dash routes or routes, something like that. I wouldn't use the same word that is used for other commands besides export, such as this type command. Because I looked at this and I thought, oh, it's a Ibgp connection, and I got confused as to what this neighbor might be. But knowing that it's an Ebgp connection, it's clear and obvious that the neighbor is going to be there. So this is that 1, 2, 3. So this is going to be .4.2. Okay, and then it's going to be family inet labeled unicast. Perfect. Okay, so now we're going to be adding. See, now this is interesting because they've only got. Oh, I see. No, I understand. Okay, so this is going to be the interface facing the internal network, as well as this. We're just going to have a BGP, Ebgp connection to that other ISP, so we won't need anything like that added there. And we won't even need that advertised into the IGP because it'll be sent using that Ibgp connection, I think. Okay, so it's going to be the one facing here, so 0, 1, 0, 1, so it's going to be G.0, perfect. Yep. Okay. Perfect. So one last piece of configuration is left. And here's that name internal. I really wouldn't have gone with that, but that's okay for now. Okay. All right. Oops, so it looks like I forgot to define the local autonomous system. It's going to be 21, 28, I can't read that. 21. Okay, so time for router E. Okay, so here we're going to have VPN configuration as well. Okay, we've got a successful commit. Okay, so they made the same mistake where they added a interface both to the default routing instance and to a custom routing instance. So this T3 interface doesn't belong there. So let's start off by set the autonomous system. So it's going to be 11023. Oh, 10023. Yep. Okay, and this is router E. Okay, and this doesn't belong there, so let's do a. But we will need to enable. Yep. Family MPLS. Okay. Okay, and now they're only going to add, yep, because these are going to be the core facing links. So 0, 1, 0, 1, 0, 1. So 1 is going to be the only one in there. Okay. Alright, so this is going to be okay, so I've got to figure out who the neighbor is going to be. Let's figure that out. So the local address, so it's going to be router H is the neighbor. Yep, that's what I would have thought. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're done with that. It looks like I made a mistake here with the local address, so let's fix that up. Okay, so on to the ISAS configuration. Okay, and it's going to be similar. We're just going to need the internal facing interface. Okay, so one last one is going to be LDP. Now it looks like they got it right for these protocols, but they got it wrong for MPLS. All right, time for the routing instance. Okay, so this is the front door, but it's going to be the front door to the first ISP. So it's going to be this interface here. So 01, 01, 01. Oops, did I do it wrong? 01, 01, 01. Oh yeah, I did it wrong. So this is going to be interface 1 goes there, but then for the other interface it's going to be interface 0. So I'll go back and correct that shortly. Okay, yep, that's what it's meant to be. The route distinguisher is going to be based on the loopback address. Okay, so I've got to figure out, so this is my Ebgp connection, so I know what my neighbor is going to be. It's going to be, we've got, let's see here, 1, 2, 3, so it's going to be 4.1. Oops, we don't need the /30 there. Okay, so now I'm going to set AS override. So yep, and we can see why this will be important. We're going to replace the neighbor AS number with our own AS number. This will prevent a loop, otherwise it will show up in the autonomous system path list that is maintained as the network layer reachability information flows through the network. It will maintain a list of all the ASs it passed through. So if we don't replace that neighbor AS with our own AS, it will think that it came from itself, which it did, but it will think that it came to itself by way of a loop, and it will prevent it from being learned in the routing table. So it's really important that we have that, otherwise it'll think that it learned it through a loop and it will reject it from the routing table because there's a duplicate entry in the AS path attribute. Okay, so we've got router E ready to go, except for one thing I need to fix. I accidentally added the wrong. Yep, so it looks good here for the routing instance, but here it's got to be changed to port 0. Okay, so hopefully everything will commit without issues. Oops, so we do have some issues here. This is good because the issues we have are associated specifically with a carrier's carrier. So we're definitely on the right track here because this is the subject we're studying right now. We've got, so it did need to be added to protocols MPLS. Oh, I see. Because I've got it wrong. Well, let's do this. So edit protocols MPLS, show pipe display set relative. Okay, so let's add the second interface to that. Okay, and hopefully that resolves the message. Nope, see, this is what I thought would be the problem here. So this means that it's not in this instance because protocols MPLS is the default instance, and this has been added to the VPN instance. So it's not, you can't add it here because this has already been taken away and used for the VPN-ISP1 routing instance. So it's not available for use for the default routing instance. But the problem with that is if I take it away, then I get to this other message where it says it needs to be added. Yeah, I accidentally did this, but yeah, let's take a look at this a little bit closer. Now, one thing I'm curious about is how it knew that it was a carrier of carrier. Because I don't see any configuration specifying that. I wonder if I need to remove it, family MPLS from it. Let's try that. Okay, so let's see if this commits. Oh, so we got the same problem here. Okay, so I think I know how to resolve this. I'll just go. First of all, I will turn this back on. I think this does need to be on. And then we'll go edit routing instances, VPN-ISP1, and now under here do edit protocols MPLS, and now set interface GE001. So this looks like it was not a part of the documentation, but this is what I'm going to need to be doing on the task is following the CLI, doing commit checks, doing help apropos, and if anything's a little bit esoteric to the version of the image, something like that, I'm just going to need to be able to handle that on the fly. It's a hard test, so I definitely will need that sort of resilience and versatility on test day. Okay, but I figured it out, so let's take a final look at the active configuration. So we do have the family MPLS knob enabled on that. I'll need to go back and set that on some of the other ones. We have the internal facing port added to the default instance for the protocols, but on the external facing port facing the first ISP, we have protocols MPLS enabled under a custom routing instance. Alright, so time for router F, and it is getting late, a little bit later than I had planned to keep working on this, but I should be good to keep going. Especially these easier ones. I think I'm gonna come up against some more difficult ones, and that might be a better place to stop. Alright, so I might need to enable family MPLS on this. I'm just gonna leave it run for now without it. I think, I don't think I will need it. I don't know, we'll find out. Okay, so, yep, perfect. Time for router G. Okay, another easy one. Now we're going to go into one that is much more difficult. So it might be good of me to consider stopping. But it's nothing I haven't done before. It's basically just a duplicate to the other ones, so it's really not going to be too hard. Mentally anyways, it's just kind of a lot of typing at the end of a long day of typing. So so I think I'm going to finish this one, and then the next video I'll just have these left to go, verification steps, but this is going to be my final router. Okay, so I'm going to add these interfaces to protocols MPLS, so I've got to toggle the knob. Okay, I'll need to toggle the knob for both of them. Alright, and now I can add them to the appropriate protocols. Now, same deal, I will only be able to add the internal facing interface to the default instance of protocols MPLS. The external facing interface will be in a VPN. So the internal interface for router H is going to be ETH1. Okay, so the external interface of ETH0 is not going to be added, even though they have it there. They made a mistake. Oops, I forgot to do configuration. Okay, so now we're going to set the neighbor. Okay, so router E, yep, that makes sense. It's going to be this one. So 1, 2, 3, 4, 5. Excellent. Okay, time for ISIS. Okay, and this is going to be 001. Okay, so we've got to set up a route distinguisher. It's going to be based on the loopback 0 address. :21 for the autonomous system, which I will be setting up shortly. Oops, I named that wrong. It's going to be with a T. There we go. Oops, so, yep, I've added a second one with a different name, so I've got to get rid of the misnamed one. Okay. All right. So this is a Ebgp connection. So it's going to be a neighborship to the physical interface. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8.2. Oops, don't need the subnet mask. And I'll need to go into that hierarchy, and then here's that super important AS override command again to prevent the autonomous system from showing up multiple times in the AS path attribute. And then this is really important command as well because it says what kind of network layer reachability information can be sent and received. Labeled unicast, labeled because it's part of a VRF, or labeled because it's going to be sent using MPLS. The VRF yeah, iNet VPN. This is the one that handles it being in a VRF. This handles the fact that it's MPLS. Oh, right, so one final thing, we're going to do edit routing options, show pipe display set relative. And you can see we're missing a command here, and that is the autonomous system that this router H belongs to. So let's look that up using the topology diagram. It's going to be 1123. I am surprised that they're using 69 here instead of 10023. I'm not sure where 69 came from. Okay, but this should be good to go, and I think I'm gonna congratulate myself for doing an after work video by just stopping here and not going too long. I think that would be a big mistake because it's more important that I do after work videos every day until the day of the test than it is that I just do one long after work video today and then don't do any more after work videos at any time in the future. Because if there's one thing I need to keep reminding myself of is that it is all going to be over and it's going to be over fast. So, okay, so this is the carrier of carrier interface. So carrier interface 0 is missing from this section here. So I will add that. Okay, and now hopefully it will commit, if I may type it correctly. All right, so committed, everything is perfect. Oops, and I got a notification there. Yeah, so the next video I'll be finishing it all up with router K, and then we'll be doing the verification steps. All right, so thanks for watching, and I'll see you in the next one.